Oh, guess what now? We get to do trig. Oh, I know, it's so amazing. So the exact same thing happens with trig. When we're doing an antiderivative, we're just going backwards with it. So if I want to take the integral here of cosine x dx, what do you have to do to get the derivative of cosine? That's sine, right? So here I have sine x, of course, plus c, because it's always indefinite. And you can always go backwards with it. What's the derivative of sine? Cosine, right? It's the antiderivative. Good, so we're just going backwards. That's what's happening. If I have sine x dx, now here's the kicker. It's right. So I've got to account for that negative, because actually the derivative of cosine is negative sine. But whenever we take the antiderivative, the cos as my answer are what's negative. Right, so we account for that in our answer. Okay, good. 3. If I have secant squared, what's the antiderivative of secant squared? Tangent. And that's why it was so important for you guys to learn those the first time, because now it's going to be super easy with the antiderivative. Cool, you've got this. See, it's not so bad. Cosecant squared x dx, what's that anti? Negative, good, and you have to account for that negative, right? Negative cotangent x plus c. What if I have secant x tangent x? That is, yep, secant. And it's not a cos, so I don't have to worry about it, right? I'm going to scoot this up just a little bit more. Number 6 here is cosecant cotangent. So which one is that? Negative cosecant. And, you know, it's the last one that we were looking at, so we know it's going to be that. So now the antiderivatives are what we're starting with here, taking it into our trig functions. All right. Good thing you memorized all those, right? Because now it's going to come in handy. It will be no problem. We just antiderivative this. All right, let's do it right now. We're going to start, and I'm just going to go with 3b here. I have 2x plus 3 cosine x dx. All right. Everything's in terms of plus or minus already. And you can definitely have problems where you have this polynomial term and you have a trig term. That's no big deal, because we're just taking the antiderivative of each piece. So I've got this 2x. When you add 1 to that, that's going to be squared. I'm not putting the plus 1 up there anymore. I'm trying to work us into it. All right, divided by that 2, because I always have to bring this in front, remember. Plus 3 is still just a constant in front, so it comes along for the ride. What's the antiderivative of cosine? Sine. And plus c. Good, then we clean it up. X squared plus 3 sine x plus c. And that's all she wrote. And it doesn't have to be negative, because remember, the derivative of sine is just regular cosine. So watch those positive and negative symbols. All right. Example 3c. Let's take a look at this one. What if I have the sine of x over cosine squared x dx? Do we have a quotient rule? No. Ooh, interesting then, right? So we have to use your trig identities. Think about what is in your toolbox. So this cosine squared, we can break this up to be a sine over cosine times 1 over cosine. Right? Oops. So what is sine over cosine? Tangent 1 over cosine is secant. Is that the best day ever? I believe it is. Because what's the antiderivative of tangent secant? Straight up secant, and you're finished. All right, so it's still trig. So you still have to look back through that a little bit. See where we are with the identities. All right. Let's do a couple more here. Here is example 4a. What if I want to integrate 2 over pi sine x minus 2 cosecant squared x dx? Mm-hmm. What's pi? It's just a number, right? Pi is just a number. So 2 over pi is literally just a coefficient number. Don't get wigged out by that. It's just 2 over pi. So what's the antiderivative of sine? 2 over pi is just a constant. Cosine, but remember, it's that negative cosine, so don't forget that negative sign in front. Same thing is happening here. I've got minus 2, but what's the antiderivative of cosecant squared? Negative cotangent, right? So that becomes a plus. Now, a lot of times in math, whenever you have your final answer, you write the positive term first, but either way is fine. But just know, when you look at my math lab or in your book or any of that, a lot of times they go ahead and just write the final answer with the positive term first. It's just a common practice. Not a requirement, just a practice. Okay? Oops, I'm out of room on this page. Let's hit one more page. I got one more example I want to do here with you on trig. Oh. Oops. Oh my goodness sakes. Try again. Example 4b. I would like to integrate 4 cosine x plus sine squared x over sine squared x dx. Ooh. It's not a big deal at all, right? Yes. You've got a monomial in the denominator, so what do? You divide it up. That's it. A single term in the denominator, you divide it up. So I have 4, and then I've got cosine x over sine x times 1 over sine x. I can't do anything with that squared, right? I can't do anything with that squared. So we're going to split this up just like we did on the previous problem. Take cosine over one of these sines and then 1 over the remaining sine plus sine squared over sine squared. That's a 1, right? Okay, so these multiply across. We have the same thing, cosine over sine squared. Sine times sine, we're good to go. But let's manipulate this a little. Cosine over sine is cotangent. 1 over sine is cosecant. The same thing on the top and the bottom is just a 1. All right? Okay. I got a little trig on this term. I've got just a number in this term. So, what's the antiderivative of cotangent cosecant? Yeah, good. Negative cosecant, right? So I have to hit negative, and that 4 is still just a constant here of cosecant x plus, and remember, anytime you just have a term by itself, you stick that x on there, and then you always have to have your plus c for indefinite terms. All right, so knowing those trig derivatives, great job learning those, because now it's not going to be that big of a deal to take the antiderivative of it. You're just going backwards. It'll take some practice, but you've got this.